Oh, one other thing. This uses a magneto. This is a very, very old design, but very tried and true. It's been around for about 60 years or so. It's used, has a federal part number to it for equivalencies, and it's in use in all sorts of military and agriculture, as well as some older recreational equipment. But it's set up. There's no chance of it firing because I don't have any of the ignition hooked up. But right here, move it right here. This is top dead center, and just a little bit after it, you hear that click, and that's the magneto. It has a coil inside, and a magnet, and a cam with a spring delay in there to like physically charge or set up a spring to be able to move a magnet very quickly across the eddy plates of the coil, so that it induces a electromotive pulse in the coil, and that with the capacitor allows that magnetic field to collapse, and that's what generates a high voltage across the gap of the spark plugs. But we've got a problem with the coil in here, so I've actually removed it. But these would fit in there and power the spark plugs. This wire here can pick up the pulse of the spark, the current actually traveling through, and is brought over here to this little device. This is a tachometer. And the carburetor down here, this is a Zenith carburetor. It is used on the Model A Fords. It's an updraft. Again, these are real reliable. They're still in manufacturing, they're still manufactured, and people who restore old cars and fly airplanes, or ultralights anyway, still use these. So its characteristics are well understood. And again, on this is a half a VW engine. You can see, the old flat VW, flat 4, would have two of these jugs on each side. In this case here, the crankcase is cut in half. You end up with two main bearings. One is right between where these two cylinders would be. This is where the other cylinder would be. And then over here, you can see just a little bit of a remnant, perhaps. Let me see if I can get some light in there. Just a little bit of the old cylinder there. And so we have a main bearing up here, and a main bearing in here that the crankshaft runs on. The crankshaft runs the magneto, and it goes straight out here to, this is the accessory side of the old Volkswagen engine. And I believe this is an aluminum rather than magnesium case. Aluminum cases are easier to machine and work on, welding and so forth. So that's why these are prized a little bit more than the magnesium cases. Also, they don't tend to light on fire like magnesium does. The jugs are pretty much the same. I think these might be oversized. They might even be manufactured by Scat. The heads are a little different. I believe these are custom made, because the old heads have actually a place for two valves, two sets of valves for the other jug. So you would have, two of these cylinders, one here and one here, and then one head that would span the two. And you'd have push rods and all of that coming out, kind of like this, but it would all be contained in one assembly. and you'd have that on each side. But the rest of the parts, being designed for a larger engine, their duty cycle or the amount of stresses that they experience are quite a bit less for an engine that's its displacement is half the size. So you have a little bit of reliability, extra reliability built into that. This down here is aluminum tubing that's used to warm. It carries oil from up here down around this kind of a jacket, and that warms up this intake manifold. This intake manifold is made out of aluminum, welded aluminum, and the updraft carburetor supplies air-fuel mixture through here. This would normally be a problem area for frost and buildup of frost inside this chamber through the Venturi effect, and so it basically has carb heat, as they call it in aircraft, carburetor heat, all the time that it's running, and that keeps this manifold free and clear from frost that can choke off the engine. By keeping it on all the time, you might lose a little bit of power because the air may not be as dense. But the good thing about keeping it on is sometimes when you detect it in a regular airplane, you're flying along, you start losing power, you figure it's a carburetor freezing up, so you apply carb heat. Sometimes until that frost or that ice inside the chamber is cleared out, or potentially worse, if it melts and starts falling apart and then running further down here, it can block parts of your intake manifold until it melts, and so you can potentially have the engine run even worse as soon as you turn on the carb heat, and then you end up with some people have been known to turn it off because that didn't seem to help, and it ends up actually making it worse because now they've got unmelted ice blocking their air. But yeah, it's a cheap solution. It doesn't deflect any warm air into the path. It just heats up the surfaces, so nothing can condensate on it. Yeah, and this here is to monitor oil pressure, and it comes over here, so that can be monitored. Inside the aircraft, Dad built a very neat little panel here. Let's see if we can see it. And the tachometer goes right here. You have oil temp, oil pressure, and then your airspeed. There's a pitot tube over here, and really, as far as flying, you have your indicator here for making a coordinated turn, and then you have an altimeter. But most of the time you're going to be looking outside the aircraft, and with your scarf dangling out here behind the turtle deck, and with a big grin on your face. And here's the windscreen. So that's about it so far.